What is the biggest con in the world of cycling tech? The truth is, I don't actually know, but I'm on a mission to find out, and I'm going to start by investigating the world of upgraded ceramic bearings. Their prices seem maximal, their performance advantages are questionable, and their longevity is difficult for us as consumers to quantify. So I want to speak to a genuine bearings expert to find out the truth about upgraded ceramic bearings. But I'm also going to discuss bearings in general to better help us all understand the technology and understand what suits our budgets and needs the best. I'm going to be speaking to Matt Harvey from Enduro Bearings, but this video isn't in association with them or any other brand. I simply reached out to Matt because I wanted to speak to a genuine bearings expert with years of experience in this field. Quick heads up though, this is going to be a deep dive, so grab a comfy chair, grab a drink, because we're going to be in it for the long haul. And better yet, put us on the big TV and watch from the comfort of your very own sofa. So I guess the first thing we should do is have a bit of background from you. What is it that's got you into bearings, and how has your involvement and time in cycling and the industry in general led to where you are now?
Yeah, I've worked at bike shops since I was 13, and I worked for several companies, including Bianchi, and working for White Industries and for Fisher mountain bikes. And so really, I think the first time I got really into bearings was probably at Fisher mountain bikes, because we were working on one of the first full suspension bikes. It was the RS1. And of course, back then it was bushings or plain bearings, which don't have rolling elements. So that's kind of the difference between the two types of bearings there are. There's plain bearings, no rollers, no balls, and then there's rolling element bearings. And at the time, ball bearings, I don't remember them being in any full suspension bikes. I could be wrong, but pretty soon after that, they started to be seen in all the full suspension bikes, because everybody realized how much faster the suspension is with a ball bearing element. They react faster over small bumps and so forth. So I was at Bianchi by then, and we were designing a couple of full suspension bikes, and we started with bushings. And by the time I left, it was bearings, ball bearings.
One of the things you explained to me was how you worked to develop a mountain bike, which was then also converted and to be used in Paris-Roubaix.
Yeah, that's right. So I designed a cross-country mountain bike. It had about 2 inches of travel, which was that was kind of standard back then. And then we converted, so Paris-Roubaix was coming up, and people were trying a lot of different things. In those days, the cobbles were in much worse shape than they are now. And it was thought that, and they were on really skinny tires. Even at Paris-Roubaix, they were still using, 27s, which fat tires for road bikes then. But anyway, to get over, it was thought that a full suspension bike might be better to go over everything. And RockShox had a 700C front fork out that people were using. We converted my cross-country full suspension mountain bike design over to a road bike, which was a challenge, because back then roadies wanted their geometry. They didn't want anything different. And so to kind of smash a full suspension bike into standard road geometry then was tricky. It only had about 1 inch of travel, really.
So did anyone famous ride the bike? What was the best result? Where did that come?
Yeah, Johan Museo rode it for GBMG Bianchi. And he was up there almost to the end. He was chasing Schmiel. He was in second place. And with about 20K to go, he got a flat tire, and they had his shoes tightened down into the pedals so hard they couldn't get his feet out. It took him about a minute to get his feet out. Mechanic had to wrench them out of the pedals. And by the time he changed bikes, 8 people had passed, and race is over, 20K to go. So, but I don't think he was going to catch Schmiel. Schmiel was on fire riding away anyway.
I mean, that in itself is a super cool story, right? But how do you go from bikes and suspensions and a little bit about bearings to diving into the world of focus just on bearings to where you are now? What has led to that?
Right. Well, so I have an old friend that I worked at a bike shop with, and long story short, his father had a forklift repair business, and he started making bearings for old forklifts on his lathe, and I started helping him with drawings. And then I started really looking at bearings and thinking about them for bicycles. And about the same time, we bought a huge surplus lot of military bearings and bearings from old machine shops to resell in the area. We were trying to make money to start the business. And I probably went through thousands and thousands of different bearings from World War II and Korean War, and I saw these different cool things, and I learned a lot. And so I just started applying some of the things I saw to what was happening on bicycles, where I thought it could be an improvement for instance, headset bearings, which are totally different from bottom bracket bearings, which are completely different from hub bearings. They all have their different particular requirements to perform well. So, and that's kind of what I've continued to do till today is refine the bearings in all those areas of the bike to perform as best as possible. There's a lot more to it than people think. I mean, people don't really think about the bearings nowadays. You can't even see them. Like that frame set you have behind you, you used to be able to see the headset. Now it's, some people wouldn't even know they're there.
Yeah, it's crazy to think how stuff has changed over the years. Your expertise and Enduro Bearings doesn't just focus on bike bearings, right? There's a whole sort of industrial side to the business as well.
Yeah, there is. So my partner has gone on with forklift bearings and bearings for drilling and all sorts of things. So he's got a much more diverse offering that he's got his head into. He might be a little crazier than me because it's a huge world. Shared information, you learn a lot, and especially when you're dealing with metals and a lot of different, rubber and silicone and all the different pieces, you learn from each other what somebody else is doing. Maybe this drill company came up with something cool that I could use,
Let's start with something really simple to start us off with. For people who are perhaps not technically minded, what's the purpose of a bearing in the simplest form?
It's basically a small machine that lets two components rotate against each other, turn against each other, and with as little friction as possible. That said, you go into this whole world of thousands of designs, from the Egyptians trying to move, stones with round cylinders of wood. People tried all sorts of things down through the ages. Balls, Da Vinci was looking at those things. I mean, there were people, the Romans built the first found ball bearings, let's say, back in Caligula's boat, had these turntable bearings made out of bronze they're still in a museum in Italy. So that's 2,000 years ago. And so the quest to try and make things easier to at first move large objects has got into machinery finally in the machine age in the 1800s, when finally you had steel and you could mass produce industrial products like bearings. And so bearings really got refined around the 1850s, 1860s. That's when we see steel bearings that we know today that you see everywhere. You don't think about it, but your suitcase that you drag to the airport, it's got some skateboard bearings, some 608s in there, and there's whole factories that just make those bearings. It's crazy.
Yeah, it's mad. So talking about, let's move away from suitcases, talk about bikes, right? All right. So our bikes rely on bearings in so many different ways. I don't know, give us a ballpark figure. How many bearings has our bike typically got inside?
Yeah, the typical bike has just a road bike or gravel bike or a hardtail, 12 bearings inside. So, okay. And it could be 14 depending on, it changes depending on the pedal design, but usually have 2 in the front hub, 2 in the bottom bracket, 4 in the rear hub, 4 to 6 in the pedals, and 2 headset bearings. So you have 2 steering bearings, which are very different duty from the rest of those bearings.
Yeah, that was what I was going to say next, is how do some of these bearings differ? Because I think most people have heard of cup and cone bearings and cartridge bearings being the most common. Explain to us a little bit more about those, and then also some of the other options that are used on our bikes.
Sure. So cup and cone bearings were the first types of bearings made. You have, essentially 3 parts. You have the cup, it's just like it sounds, it holds the balls. The cone, which will drive the balls. The balls are the third part that are inside the cup, and then you adjust them. You need some kind of mechanism to preload the bearings and locate them in the cup, take the play out. So cup and cone, usually there's 2 opposite ones that drive against each other. And it's very similar to a headset bearing. If you think about a headset and you have to preload your headset, that's a pretty typical cup and cone setup. And the original headset bearings were all cup and cone. Nowadays, they're what we call cartridge bearings, which those were developed during that industrial age in late 1800s. And basically, the bearing is made at a factory, and it's preset, like the balls and the 2 races. The internal clearance is set, so you don't necessarily need an exterior threaded system to hold them together.
Probably the most common type used on bikes, you would say, in the modern era?
Yeah, it's all moved to cartridge bearings, which really changed around the time I was starting this 30 years ago, because there was still a lot of cup and cone systems made, and cartridge bearings, they're completely different factories, completely different systems. So it really changed about 35 years ago to cartridge bearings.
A question that I often am asked is whether a chain has got bushings or bearings, and what's the difference between them?
Well, they are plain bearings. So the bearing is inside is a the ring, if you will, is rubbing on another metal surface, and they're rubbing against each other. Now, where it slightly differs, where it kind of becomes a hybrid of mechanical design, is the roller actually does roll over the chain rings, that metal roller, but the metal roller is rubbing on the inside of itself. So it's kind of like a donut. On the outside, it's rolling, and on the inside, it's rubbing. But officially, it's a plain bearing, really.
Okay. And then, so some of these, let's focus on mainly cartridge bearings, for example, if they're the most common type on our bikes. Was a clear-cut ranking of order of priority in terms of what constitutes to make a great bearing?
Steel first, clean steel. Second, proper heat treating. Third, seals. Fourth, grease. Of course, you've got to have everything, right? But that'll be my priority list, I'd say. You have to start out with good steel, or in the case of ceramic balls, good ceramic ball and manufacturing techniques before you can say the word quality, I guess. So the main thing is really clean steel, and clean steel means less pollutants in the steel, because the purest steels are the most expensive steels. So how do we get there? It takes a lot of energy melting it properly in certain kinds of furnaces to get extremely good steels. And so that's the first thing you need. And there's not every foundry can produce really clean steels. Some factories don't really care about clean steels. They're making steel for things that don't matter, but we do, because we're Formula One. We want everything top end. So we have to look for the best steels. Next part is machining them or grinding them and machining them. But these days, that's the equipment is so good. It's generally pretty good, from less expensive bearings to very expensive bearings, because the machinery has come so far. The next part that's really critical, though, which I would say is number 2, is heat treating and how you finish things and assemble. seals and grease are extremely important. After you've made a really nice bearing, they're extremely important because you have to keep the dirt out. You don't want the water coming in. You don't want your sports drink spilled on your bike coming in. You don't want salt water thrown up from salted roads coming in. And you want to keep the grease in. So it's tricky. There's a, I don't know, there's 100, I was going to say 100. There's at least 50 ways to make seals. Maybe there's 100, but people have tried everything. So, but yeah, it's always a tricky balance between the bearing rolling well and sealing well, because you don't want too much friction. Friction on seals is actually one of the places where that's where you encounter the most friction, or let's say wattage loss in a bearing, is through the seals. And for instance, if you have the difference between a dry seal and a wet seal is about 20 times the friction. So you want to make sure it's lubricated with grease.
God, that's a big difference. I knew that the seal made a big impact on bearings or performance and friction and stuff like that, which actually leads us in a nice way to the most important question that I've been dying to ask you is, are really expensive, like upgraded ceramic bearings actually better than normal ones? Now, I know that is a very broad and bold question, but I think we need to start to pick it apart a little bit to explain for people.
I was resistant to ceramic hybrids when they first came on the scene, and there were a lot of claims about ceramic hybrids of wattage savings, several watts. And it's just not possible, because a typical bearing uses about a quarter watt, whether it's ceramic or steel. So if you add up all those bearings, you're talking about 2 watts on your bike of drag. Most of that comes from the seal. Ceramic balls on paper and if you do the math, theoretically, the ceramic ball has less rolling resistance on the steel race than steel balls. I haven't been able to measure it. It's a really small number. The big companies have done a lot of testing, like SKF and NTN, of course. And for instance, that seal drag number, that's from those guys, not from my information, because I've actually never done that particular seal test. Getting back to your question, however, when you do put ceramic balls in on steel races that are good, there is theoretically less rolling resistance. And people will tell me all the time that they can feel it. But on testing, I haven't actually been able to find it. There is a difference with seal design and the longevity of bearings. Now, all bearings are really good right out of a box when you put them in there. When you put them in your bike, day one is the best day, right when the grease gets spread out and everything is good and you're going along. But the real difference is maybe weeks or months or years. How did they perform then? And that's where there's big differences in bearings. They can really drop off fast. Like even a month later, they start to wear or gall or pit. We've always designed bearings at my company for longevity. That was my whole thing, is like, let's find something that lasts a really long time. And I don't want to like mess with my bike. I want to power wash it after I finish riding it. I want to hang it up wet, and then I want to get out and ride it again. So that's kind of been my criteria of like what most of us would do, because we don't have a Tour de France mechanic that changes all our bearings out every couple days. Well, at least I don't.
Yeah, I mean, it would be nice, wouldn't it? It would be nice to have that luxury. So if some of these frictional losses are perhaps not as good as they seem on the face of it, we can dive into longevity in a minute. But what I want to discuss is perhaps the price that is associated to some of these products, because it does seem difficult for the average person to look at what seems to be 2 identical products, but one could be £5 or dollars and one could be £100 or dollars. Like, how have we got to that point?
Well, I know it seems incredible sometimes. There is some justification to it because, for instance, most bearings are made out of 52-100 chromium steel. there's huge differences in that steel when you buy it, and you can buy it for anywhere from $1 a pound to 50 times that, and you get what you pay for out of the foundries. That's just buying steel at the beginning. It's not buying a brand name or anything. So then heat treatment processes can vary drastically in costs. There's a lot of processes to making really good bearings. For instance, a lot of heat treating is just in what we call flame baskets. The rings are machined and then they're in these open air flame baskets. Well, there's pollutants in the air, there's carbon in the air, there's all sorts of pollutants that come in while you're heat treating. Or you can do vac heat treating where it's in a completely clean environment with heat induction, and it's a very clean, constant heat treating where you're guaranteed there's no warpage in the materials and stuff. So there's, in the background of those two bearings you're looking at in your hand when you see them, they do look the same, but they could have vastly different backgrounds as to how they got there. It's kind of like, maybe a parallel I'm thinking is sometimes with knives. Somebody who's really made an incredible knife to something that's stamped out of a factory somewhere.
So material costs are one of the big issues here. So have you got any examples of the difference between, say, a steel ball and a ceramic ball?
Yeah, steel balls are pennies, and then ceramic balls are dollars. So let's just put it that way. And then there's a big difference between cheap steel balls and good steel balls. There really is. So and then cheap ceramic balls and good ceramic balls. And the cost differential can be 50 or even 100 times. So that's a second element, because we've just talked about races. Now you've got balls, and then you even have seals and grease. There's differences in those too. There's really terrible seals that are made out of kind of hard, lousy rubber that doesn't seal your bearing. And then there's really good silicone material that you can use. If you look at the bearing like a complete bike, you could look at it from your $200 department store bike up to your $12,000 high-end bike. There are reasons for it. Now, of course, you get diminishing returns at the top, but that's like everything.
I think it would be nice to have some clarity on what actually is a ceramic bearing, because I think there's two aspects to this. You've got a full ceramic bearing and a hybrid ceramic, and I think there's a lot of confusion. So give us an explainer on what the difference between the types are and why the differences exist.
Sure. So there's full ceramic bearings are just the way it sounds. The races are actually ceramic as well. And there's actually 3 different kinds of ceramic. I'm not going to get into that. We only use silicon nitride, which is the black or dark grayish color you see. And then there's ceramic hybrids, which you pair a ceramic ball with steel races. And that's 98, 99% of the market these days. The reason we don't use full ceramic bearings and we don't offer them is we tested them and they fail catastrophically. It's like having ground up glass inside your component. It's not very good. Ceramic balls, because of their spherical form, are super strong. It's like our planet. It's the strongest form you can have. So there's no problem with ceramic balls. The races are trickier to make. So what we have are ceramic hybrids, and those are ceramic balls either on 50-100 chromium steel or on 440C stainless or on nitrogen steel races. So in my mind, there's 3 types of steels races you can use with ceramic balls. And that's what people do. That's what we see in the market right now. We don't pair ceramic balls with 440C because I believe it's too soft, and it's about 20% softer than chromium steel. It won't rust, but the ceramic ball is just too much for the material in our testing and my mind. So we do make bearings using ceramic hybrid bearings using chromium steel, which is harder and can resist the ceramic ball. However, you always have to have grease on it. They have to be clean. Once you start running a ceramic ball on chromium steel, it's starting to what they call micro crack and then gall the bearing. So eventually, on good ones, they last 2-3 years for a rider who's riding a lot. Bad ones, it could be weeks or months sometimes. There are some steels, however, there's these nitrogen stainless steels where they don't use carbon to harden the steel. It's actually hardened by nitrogen, and it's a remelted, what they call a remelted stainless steel. So it's extremely clean. So there's no pollutants in there. That's another thing that can start to kill steels. So when you run the ceramic ball over it, you don't get the micro cracking. You don't get the galling. It just burnishes the steel, and it won't corrode because it's stainless. So that's like the one ceramic hybrid that I think surpasses an all steel bearing, a well-made steel bearing, I should say.
What I want to talk about next is, I think, where a lot of people get their first taste of ceramic bearings. It's social media, okay? Everyone's seen all the videos of people spinning the pulley wheels and they spin forever, or spinning a bottom bracket and it spins forever. So, like, what's your thoughts on this?
You know, the cheapest, let's say, metal skate bearing, you can set that thing up with some sewing machine oil and get it to spin like seemingly forever. You know, just flip that thing over, blow it out with some compressed air, and put some, even if it's completely worn out. In fact, the more worn out, almost the better. It'll just spin and spin. But that doesn't tell you anything about how that bearing performs under load. Once you've stepped on your bike and you're pedaling it, it's an entirely different thing. You're putting all these axial forces from your pedal motion and everything, and sprinting or climbing up a hill. And now that steel skate bearing might lock up or skid, or those balls are not rolling particularly well. It's like kicking tires at the tire dealer. It doesn't mean anything.
Yeah, I think that's a good way of putting it. I think let's all just accept the fact it looks cool on the internet, but it doesn't actually translate to real life performance of bearings.
Exactly.
So we've mentioned about, you've said the loads vary once you step onto the bike and you're outside riding it. So how are they affected by the load? We're talking about bottom brackets, for example, or wheels.
Let's look at the rear hub, because that's another engineering and mechanical challenge, and not as easy to make a nice rear hub as people think. It looks simple, but it's really not. And we've really challenged the rear hub in the last few years, like I said, because now we have through axles, which are good in one way because it stiffens everything up. But now you have a larger hole in the rear hub, if you will, and you still have the same dimensions essentially on the outside. So now you have some thin bearings inside the hub. Well, you have to strategically place those bearings in the hub to resist the forces that you're putting it through. Let's think about the chain way out on the 10 tooth, and you've got some pro rider putting out, 1,000 watts, crazy wattage, all the way out there on that little cog. It's twisting that whole thing up. It's cantilevered forces from outside. And the two bearings that are between the hub shell and the cassette are really under a lot of stress at that point. And so if things aren't like strong enough or stiff enough or well made enough, the balls in the bearing can actually skid. And then you have disc brakes on the other side. So you have this wind up force on the outside. So, outboard bearings used to be kind of innocent out there and not having to do anything but just kind of coast along. But now they're under a different kind of stress, an opposite stress the heavy windup of the disc brake.
Is that probably the same concept that has happened with headset bearings with integrated hoses, trying to make the bearing as small as possible for the frame to be aerodynamic, but then you've still got to fit everything internally, so then it leaves less space for the bearing?
Sometimes the last thing somebody thinks about is the bearing that has to go inside, I find. But, I'm always championing the bearing here. But come on, go for a bigger one, the last life of the bike. But yeah, you're right. We've started putting the cables down the middle of the steer tube, and the hole got much larger, from 40 to, or 32 to 40, 44 millimeters. And then you've got a bearing that has to be 50, 52. And you got to get a ball in there too. You have to, you have to fit things in. The ball gets very small. And if those bearings aren't very good quality, you can ask some mechanics. You'll get some good answers about having to change those bearings out, because they got to pull all the cables out and redo the hydraulics and everything. They're sometimes too thin and they don't last very long.
It seems to be a shame that longevity doesn't always come at the top of the priority list, but I think it can do in certain applications. Talk to us a bit about longevity with some of these more performance-orientated bearings.
That's what I've always been looking for first, longevity. I'll just say this, like if you go after that first, you get efficiency and better wattage, let's say numbers when you pursue that spot. So the number one thing that attacks bearings is corrosion, and that's the first thing that takes bearings out. So we spend a lot of time on chromium steel bearings with the sealing and aspects and the grease, because that's what's going to protect the bearings, and that's what's going to have them last a long time. The other longevity story is, again, nitrogen steel bearings with ceramic balls. Those bearings can actually last the lifetime of the bike. That material, nitrogen steel, was made for ceramic balls. It was developed by Airbus, and it was actually developed as a lifetime bearing for Airbus. They use it as control bearings in the wings. And so that has to resist de-icing compounds, salt water, everything. So there's a couple of foundries that make this particular steel in Europe. And there's other companies making bearings out of this material, but mostly for steel mills and some other very let's say high traffic factories where they don't want to spend the money on the labor to change the bearings out. They want that factory to run 24/7. So those can be found on bicycles. I guess I have to say we do offer them, but those are lifetime bearings that will resist any kind of corrosion. And when the ball rolls over those, even if it's skidding, it burnishes the bearing. It doesn't particularly, it won't begin to micro crack or gall the bearing.
So on that kind of basis, if we're talking about good quality upgraded bearings, are they good value for money in terms of price for watt saving, and how do they compare for price against bearing life? Which do you think is good and which do you think is not so good?
So I've talked to people who've tested wheels, and it's tires and aerodynamics first, and somewhere way down in the story is wattage of the bearings. They usually couldn't find that number because it's pretty small, and it could be the error of just the test. So the way we got to wattage testing was we had to amplify the loads to get full wattage numbers. So we amplified the load on the bearing while we were testing it to a point where we could get full wattage numbers. The main thing we got out of it was that pretty much all the bearings were the same, ceramic or steel, when you first started them on the machine. The little differences between seals, there were those differences, but if you have, let's say, seals off just bearings, there was no difference between them. And then as time went on, that's when it changes and bearings become less efficient. So Nitrogen steel bearings actually get a little bit better after about, let's say, 6 months of use, because believe it or not, the ceramic ball actually polishes the race. And again, it's a real small number. It's way down there, but it actually gets a little better. Whereas all chromium steel bearings start to get worse. The wattage numbers will go up after you begin the testing, to the point where they eventually fail, which is hopefully a few years from now.
Hopefully that clears it out for people that really don't focus on the watt savings, think about longevity, and the investment in the bearing is for making it last longer, which is going to mean you're riding your bike for longer and spending less time and money at the bike shop fixing it, hopefully. You've mentioned briefly throughout our chat ABEC ratings. So what can you give me like a super brief summary of what is that?
It was developed by NASA to pick out, years and years ago, to pick out good bearings from lesser bearings, if you will. So there's like 26 parameters of ABEC testing. And it does give you an idea of the quality of the bearing. Unfortunately, for cycling, it's not really the end story at all. It's the beginning. So when I first started this, for instance, we designated bearings by ABEC 3 and ABEC 5. So the scales go in odd numbers. It starts with ABEC 1 and then goes up odd numbers up to 13. They don't tell you how well it's going to take axial loads or the forces or high loads and low RPM of the cycling industry. For instance, we stop at ABEC 5 because that's where we get the tolerances that are needed for a rear hub. A lot of times when you push ABEC 5 bearings into a hub that's not very well made, the bearings become ABEC 1, if you will, because now things are so misaligned that you're not making use of the ABEC 5 tolerances. If you make ABEC 7 and ABEC 9 bearings, there's no way you can utilize those tolerances in bicycle machined aluminum hubs and parts. So ABEC 7 and 9 bearings, for instance, are used in spindles for machines to make bearings, or lathes and so forth. Those are like spindle bearings. And they're usually real ABEC 7 and 9 bearings are, $500, $600, $700 each. They're very expensive bearings.
But it is a complicated problem to solve. That's why the bike industry still hasn't got it perfect 100% of the time. And a lot of that falls down to the use of carbon fiber in frames, could you say?
Now, of course, you can put metal inserts into carbon and make everything straight. But, then you get into, well, that weighs 30 grams more, so we're just going to use this hard carbon, and you're going to press the bearings into the hard carbon. And that didn't work out very well because that wears out. But one thing you can do with the bearings is use larger balls, because the larger balls you have in the bottom bracket system, if you can fit them in there or somehow design around that, they can take more misalignment than really small balls. So if you think about it in a real radical way, let's say you've got little teeny tiny pinballs almost the size of like 1/16 inch compared to 1/4 inch balls. If you fit up the like a cup and cone situation, you can kind of imagine that the larger balls will take more misalignment than the really teeny tiny balls. Like if anything's out of alignment, those things are going to pinch and skid. So I spend a lot of time in that area on bottom bracket bearings to try and increase the given diameter of any ball into the system.
A bit of a fun question for you next. What would you say is better, a low quality bearing, high quality grease, or a high quality bearing and a low quality grease?
Yeah, that high quality grease won't save that low quality bearing. It'll buy it a few hours or something. But so a high quality bearing, nitrogen steel bearing, you can have no grease in it. Grease doesn't matter. You can put any grease in there you want, or you can run it with no grease. Now, it makes a little more noise when you have no grease in it, kind of rumbles along, if you will, but it won't deteriorate the metal. Now, ceramic hybrids with chromium steel races and and ceramic balls, you need high pressure grease in there. The higher the pressure, the grease, the better it is to have a coating in between the ball and the race. Because once the grease is gone on those, it's a matter of days or weeks before the bearing's gone. But yeah, back to your original question, I'd take the high quality bearing every time over the grease.
But that also then means something that we've seen over recent years, certainly in the bike industry, correct me if I'm wrong if it's a technology that's been around for longer already, is solid lubrication. So we're seeing it in headsets with the sort of, I don't know, the tagline that it will last a lifetime of a bike because there's no grease to wash out. So give us a bit of an insight and explainer into what it is that this technology means.
Yeah, solid lube's been around for a number of years. It finally became popularized, if you will, during the Gulf War because they used it in Desert Storm, in tank bearings, tapered roller bearings, and so forth. So what is solid lube? Solid lube is a foamed polymer that has all these microcells in it, and you inject it inside the bearing. It completely covers all the rolling elements, the entire inside. And then there's oil inside of it, inside of the microcells. And as the balls or the rollers start moving, the oil comes out and lubricates the rolling elements. And then, yeah, there's no room for water or dirt to come in and foul the bearing. So we started testing it. We came up with our own formula, and we were using it for a while. But what we found was, after a while, a couple of years in field testing, which that's the other kind of testing we do. You have to do field testing and machine testing because you can't see everything in the shop. After 2 years, the oil was displaced by water, and then it rusted up the bearing pretty quickly. So we had to come up with a new formula for ours, which we have, and now we've released them. So we have a formula that will last years in there. It's basically a different kind of oil. So it worked well in Desert Storm in the super dry environment, and as did ours. But wet environment has been challenging to me with solid lube. I see them on other people's headset bearings. We don't do it on headset bearings because there's not enough room in a headset bearing to get enough solid lube to cover everything. The sort of architecture, if you will, of a headset bearing, like those really small ones that pass the cables through and so forth, you can't get a full injection shot of the polymer to completely cover everything efficiently enough for it to work. So we haven't, the place where we're using it is in suspension pivot bearings, and it does seem to work really well there. For suspension pivot bearings, you're going to go buy 16 of them, right? Or 12 or 16. So you don't want to really, how many people are going to spend $100 a bearing on their suspension pivot bearings, you know? But solid lube is a good compromise, I think, in that area where you're not spending all that money and you're getting some really good performance where you don't have to do any maintenance for several years. But it may not be the ultimate solution, let's say.
So does it give additional drag into the bearing? Would you ever see this technology used in wheel bearings, for example?
A lot of the solid lubes there's a ton of drag. I won't name names, but some of them are like, wow, you can hardly move the bearing. We have a formula that's kind of a waxy formula that doesn't have a lot of drag in it. But yeah, depending on the solid lube maker, it can vary quite a bit.
Conscious we've been talking about bearings for a very long time here, but what do you think the future holds for the bearings industry in general? Are we going to see bearings that can last a lifetime, ones that seemingly spin forever as well? Over to you for this.
There's a lot of research and new things coming still in steel. Steel is, people equate it with being heavy, but it's a fantastic, interesting material. And there's so many different alloys and things you can do with it. And there's actually more on the horizon with bearings because of the different steels, and then their costs changing too. For instance, those nitrogen steels, we're going to see more of that. It's kind of like the beginning of carbon fiber. You saw some carbon fiber and now it's everywhere, but you'll see more of that in the next 10 years. So we'll see some interesting things, I think, with bearing, and maybe lifetime bearings. I don't know what price point, but it'll come down. It'll come down in price.
I think if we were to try and give a bit of a summary, because I know we've had a bit of a deep dive on this, in terms of how people's mindset and approach can be towards performance bearings, let's say in particular the ones with a high price tag. What should they look for? What should they prioritize? Do people need perhaps educating more on whether bearings are going to offer the advantages that they think they're going to offer them?
Not everybody can afford $100 per bearing if you're going to change all your stuff. First, it comes down to economy. You can get really good bearings for, $10, $15 each. They're out there, they're available, and they perform very well. So it kind of goes, well, how much do I ride this bike? If I ride this bike once a month, and I've used my bike for this long, and it's well, I'll just get some replacement bearings, reasonable replacement bearings that are good quality, good grease, good seals, reputable company I'm buying them from, and they're going to be fine. If you're a real serious rider and or a recreational rider and you're power washing your bike all the time and you don't want to do maintenance, there's answers for that too. So, I'm busy. I'm not a pro rider I'm a club rider at best. But I want to just, when I have time, I want to go out, jump on my bike and just ride it and not work on it myself. So, I kind of even if I didn't work for myself at this company, I guess I would opt for some higher end things that I didn't have to think about. But I guess it depends on your, what you're looking for. If you just bought a really nice bike and the headset bearings went out, and now you have to pay a mechanic for 4 hours of labor to change the cables and rewrap your bars and everything, I would definitely buy stainless steel bearing replacements, because the offset in cost per that labor for the job just went out the window. And then there's certain places where you should upgrade for sure. If your bottom bracket bearings are going out once a month and you're a cross racer, or you're just a recreational rider and your bottom bracket is you replace them every month or 2 months, okay, so it's a $30 bottom bracket, but you're replacing it really often and you got to pay the shop guy to do it, or you're doing it yourself, but it's just wasteful. You're just throwing this stuff out. I'd invest in a better bottom bracket. I mean, it's just so that's going to last several years, or maybe the rest of the lifetime of the bike. You don't have to think about it, and it's less wasteful, and maybe you'd spend more money if you just keep replacing those bottom brackets. I don't know.
Yeah, I think longevity is a good point, and I think everyone could and should be more mindful of this across the whole of the bike industry, not just bearings. I think creating products that allow people to ride their bikes for longer and further, and without the need of just having disposable stuff that needs to be thrown away every few months. I think we could all learn a lot from that, really, I think, in that perspective. I think that's a great way of ending, really. I think we've covered everything I could possibly think of about bearings. Matt, it's been mega speaking to you. Appreciate you taking the time to go through it all.
Well, that was a lot of fun. I appreciate it.
So there you go, bearings are a complicated subject, even more so if you dive into the subject of upgraded ceramic bearings, and never in a million years did I think I'd be able to talk to Matt for quite as long as we did. For me, perhaps the biggest takeaway is that there is a huge difference in quality between lots of different brands, and whilst there's no doubt that ceramic bearings do offer advantages, it's that those advantages are typically much smaller than lots of people and lots of marketing would suggest. For me, perhaps one of the biggest advantages is the promise of greater bearing life. Although, as Matt explained, the bearings are only one part of the system. So if the tolerances of the other parts are poor, it's very difficult to extend bearing life simply by fitting an upgraded ceramic bearing. So there you go. That is more than enough chat about bearings. I hope you found this video informative and helpful. If so, please do give it a big thumbs up. And also, I'm keen to hear everyone else's thoughts on this, so get involved in the comments section down below. And if you want to show your support for GCN Tech, well, share this video far and wide for all your friends to see and consider subscribing to our channel. Right, I'm out of here. See you later.